Okay, so today I'm going to talk about how slopes change. So what's changing between this black line and the red line? Elijah. It's changing from a positive slope, see how it's positive, and the red line's negative slope. What about in this one? What's changing here with my y-intercept? Anybody tell me? What happened from here to here? Matt? It shifted down 4. You see that? Here's my line, and it shifted down on the y-intercept by 4. So we're going to talk about those shifts today. I will be able to graph linear equations in slope-intercept form. I will be able to explain how changing the slope or y-intercept can affect a linear equation. Okay, so let's talk about this family of graphs. So y equals x. That is what we call our parent graph, or the mama graph. All graphs begin by looking at y equals x. So what is my slope right here? It's 1, right? Don't I have an invisible 1 in front of there? If it was 0, it would be y equals 0, right? So if I have a slope, why is my eraser not working? What's my y-intercept? Do I have a y-intercept here? I don't. It's 0, correct? So my parent graph always starts at 0, and it has a slope of 1, or up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Or I can go negative 1, negative 1, negative 1, negative 1. We talked about this yesterday a little bit. Okay, so let's graph that. It's always going from one side to the other. There's my parent graph. All right, so every graph has his or her features, but with some of their own individual features. So that's what we're going to talk about. All right, what would happen if we changed the coefficient of x? So the first thing I'm going to do is I'm going to graph y equals x again. I'm going to start at 0, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Pretty easy. I just know it goes straight through my origin, correct? So what do you think is different between y equals 2x and y equals x? What changed between this one and this one? The slope changed, right? By how much, Klaja? It changed by 2. It's twice as big, right? If my original slope is 1, isn't this one twice as big? So, what's my y-intercept? My slope is 2. What's my y-intercept of this graph? 0. So I'm going to begin at 0, and I'm going to go up 2 over 1. Up 2, am I going to go in the right direction or in the left direction? I'm going to go in the right direction. Up 2 over 1. Up 2 over 1. Up 2 over 1. What's different about this graph from the other graph? I heard it. It's steeper. See that? This one is steeper than this one. It was originally just like that, right? And now it's steeper by how much? By a factor of 2. Okay, so I'm going to have you guys copy this down now. All right, so let's move on to the next one. What if my coefficient is negative? So I'm going to do the same steps. I'm going to start with my parent graph, which starts at 0, and it's up 1 over 1, up 1 over 1, up 1 over 1, or Philip, like you were asking, it's straight through the middle of this, right? It's right through the middle. The parent graph is always right through the middle. Okay, so this graph is y equals negative x. Now, doesn't it still have a y-intercept of 0? So what's the only difference between the slope of my parent graph here and my new graph? My slope is negative 1. So you guys can't do this, but I can because I have technology. I'm going to change the color of this. And so does everybody agree? This is the same line, same slope?
Yeah.
Only I'm going to flip it. I'm grabbing the wrong thing here. There we go. Let's try that one more time. Here is my line, and I'm going to flip it. You see what happened? Same line, same y-intercept, only flipped in the negative direction. Or, if you guys were to use it, you would start at 0, 0, and you'd go up 1, and in the negative direction 1. Up 1, negative 1. Up 1, negative 1. So go ahead and graph your two lines. All right, so recording again. So what is this one? How does this one look different? This starts off with a +3. What do we call this? That's the y-intercept. So if my y-intercept is 3, what's my slope of this line? 1. So how is it different from my parent graph? You're going to see right now, Philip, why we keep doing the parent graph. There is a reason. If that's my parent graph, how is, I'm going to do this one purely conceptually, copy and paste, change it to a blue. How is this graph going to look different from my parent graph? See how this is my parent graph here? What's going to change with it? It's going to be changed by 3. Johnny, what do you mean by 3? The y-intercept is going to shift up 3. See that? Same slope, only shifted up 3. Let's see how we would graph that. We always begin with our y-intercept, right? We'll begin with our b. So I'm going to go up 1, 2, 3. My slope is 1, so don't I go up 1 over 1, up 1 over 1, up 1 over 1? You guys starting to get it? I'm trying to get you to the point where you can look at this line, this linear equation, and tell me what the behavior of the graph will be just by looking at it. That's the direction I'm going. You should be able to graph something and look at the equation and go, hey, that doesn't look right, because it should be shifted up 3. See what I mean? Just like we did in that first exercise, where I gave you a line and you decided which equation was not true, depending on what characteristics it had. It's the same kind of thing. Okay, so make sure you guys have that copied down for your notes. All right, so let's look at another one. Here's 2C. Jesse, what's different between this one compared to the last one we did? It has a -3, right? So what do you think is going to happen? Let's predict. Here's our parent graph, right? Let me make a copy of that parent graph, and let's see what's going to happen to this. Let's color it blue. What do you think is going to be different between this graph, the blue one, and the black one? I'm asking Jessica. It's going to shift down 3. Exactly. Right? So let's graph that. My y-intercept is what, Jesse? Not just 3. What's attached to 3?
Negative.
Negative 3. And what's my slope?
1.
No. 1. Good. So if I start at negative 3, I'm going to begin at negative 3, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Philip, are you starting to realize why we have a parent graph now? Good. Give you guys a second to copy that one. Okay, so let's talk about putting it all together. Raise your hand if you have a prediction of what you think my parent graph, how my parent graph is going to change. What do you think, Philip? Here's my parent graph. Copy and paste it. What's going to happen to it?
It's going to go down.
It's going to shift down. Perfect. And it's going to get steeper. So I'm going to take that graph and I'm going to make it steeper by how much?
2.
By 2. Let's check and see if I'm right. Well, maybe if you were paying attention, right? Okay, I didn't think so. I thought you guys were talking back there. Okay, so let's try it again, Levi. So I'm going to take this line and see I've got a negative 3. So that means my y-intercept shifts down 3, correct? And the 2 in front of the x is my slope. So my slope is going to be twice as steep. Remember our first example? How a 2 in front of the x made it twice as steep? So I'm going to take my graph and I'm going to make it more steep. Now let's show you how. I'm going to show you. I'm going to check because I was just eyeballing it, okay, Levi? So where do we always begin? At our y-intercept, right? So I'm going to begin at negative 3. I'm at negative 3. And I'm going to move up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. See how I did that? You guys copied that one. All right, let's try another one. This one's 3D. Levi, take a look up here. How is this equation different from my parent graph? What's my y-intercept? So it's going to be what? Shifted up how much? Shifted up 5. So here's my parent graph. Copy and paste it. Uh-oh. Copy and paste it. Change my color. It shifted up 5. Check this one out. I want you guys to pay attention, not be graphing right now. Pencils down, eyes up here. So my y-intercept is at 5, so that means I shifted from here at 0 up to 5. What else is going on right here? It's a negative slope. Let's address that later. What's the slope here? 1 over 2. So if a slope of 2 makes it twice as steep, what do you think a slope of a half is going to do? Make it half as steep. So I can take this and I'm going to make it half as steep. Okay, we'll check that in a second. But did you see what I just did? Instead of it getting steeper, I made it half as steep. Now what's the last thing I need to do to my line? Make it negative. So I'm going to take that line and I'm going to flip it in the negative direction. Only it needs to be up at 5. There it is there. Let's check it and make sure it's right. So if my y-intercept is 5, I go up 5. And then I'm going to go up 1 over 2, right? But in the negative direction. So up 1 over 2. Up 1 over 2. Up 1 over 2. See how that works? Get it? Half as steep. Wasn't this one twice as steep? See how it's a steeper line? And this one is half as steep, but in the negative direction. So everything that's going on with this equation is affecting my graph, right? It's making it steeper or less steep, and it's shifting it up or down. Okay, so what did you learn today? You learned about how you graph based on a parent graph, right? What is a parent graph? Who can tell me what a parent graph is? Kaija. Y equals X, right? Straight through the origin. The person next to you is absent. Joshua, how would you explain the effect of adding or subtracting a constant? So here's your constant. So what happens when we add a constant? What happens to our graph? Okay, so if this number is positive 5, what does that do to our graph? It makes it go shift up. And what happens if it's negative? It shifts down. Good. All right, so who wants to volunteer for this? On your assignment sheet, y equals 2x plus 5. Perfect, Philip. The line is what? Twice as steep. Excellent. The line is 2 times as steep and shifted up by 5 units. Excellent. So the rest of that's homework, guys, and you guys have 15 minutes to finish it. Good job.